In the second part of 5.4, we're going to talk about inverse trig functions, just very briefly, very generally, and then in chapter 6, we're going to have a whole section on inverse trig functions and do much more of an in-depth study of them. I had mentioned to you already that the button that looks like sine to the -1 or cosine to the -1 or tangent to the -1 is not to the -1 at all. Now, if I say write x to the -1 with a positive exponent, you just say, hey, I see a negative exponent. I think the word reciprocal, take the reciprocal of the base. It's 1 over x to the +1. But when you see sine with a -1, what looks like an exponent and actually is not, and somebody knew this already, that's the inverse sine function. And what looks like cosine to the -1 is the inverse cosine function. And we've talked about inverse functions. You know that they're undoing functions, functions which undo other functions, just like taking a square root undoes squaring. Taking the inverse sine of sine undo each other with certain restrictions. And we've got to talk about what those restrictions are. But the inverse trig functions just undo the trig functions. So if I say theta equals some trig function with what looks like an exponent -1, but it's not, that could be sine -1 or cosine -1, tangent -1. I'm not even going to read it that way. I'm going to read it inverse sine or inverse cosine or inverse tangent. Another way that it can be written, and I wish this is the only notation there was because it's not going to be confused with the reciprocal function, arc sine, arc cosine, and arc tangent, all of those are much more clear than this notation. But both of them mean that theta is the angle whose trig function is x. If theta is inverse sine of x, that means theta is the angle whose sine is x. If theta equals inverse tangent of x, then theta is the angle whose tangent is x. And be very careful with this notation. This does not mean the reciprocal function like this does. All right, the next problems, the problems that I didn't mean to ask you yet, say approximate the acute angle theta to the nearest 1/100th of a degree and to the nearest minute. But both of those are in terms of degrees or minutes. So when we're doing these problems, I want you to make sure your calculator is in degree mode. If the directions tell me that I want to approximate the angle to the nearest degrees or minutes or seconds, then I'm going to make sure the calculator's in degree mode. If I want the calculator to give me the angle in terms of radians, then I have to make sure my calculator's in radian mode. It will give me an answer in whatever mode that I have it in. All right, number 26 says solve sine of theta equals 0.6612. That means find the angle whose sine is 0.6612. There are actually two angles on the unit circle where sine would be this number. Sine is the y-coordinate. So in what two quadrants would sine have a positive value? Sine is the y, and the y is positive in 1 and 2. But these directions say approximate the acute angle. That means for these problems, I only have to give the first quadrant angle, whose sine is 0.6612. Now, that's not a value that I have memorized on the unit circle. I can tell you the angle whose sine is a half, or the angle whose sine is square root of 3 over 2. Any y value that I have memorized. But this is not a y value I have memorized, so I'm going to have to use the calculator to find the angle whose sine value is that. I just enter on the calculator inverse sine of that. Again, make sure your calculator's in degree mode because you're wanting your answer to be in degrees. When I entered that on the calculator, I got 41.39 to the nearest hundredth of a degree. And then I just used my degrees, minutes, seconds button and rounded to the nearest 1 minute. To the nearest 1 minute, I got 41 degrees and 23 minutes. It's not either one. It's a y value. It's a y coordinate of a point. So this 0.6612 is not degrees or radians. We're looking for an angle. And if my calculator's in degree mode, the calculator will give me that angle in degrees. If it's in radian mode, it'll give me that angle in radians. In these problems, in some later problems, it says, give me the same thing in radians. Yeah, but just read the directions, to see which mode to have your calculator in. All right. When we say that sine and inverse sine undo each other, that means if I take the sine of 41.39 degrees, it better give me back the 0.6612. And sure enough, I can punch it, and it does. But that's the first quadrant angle, because the direction said find the acute angle. So it's the first quadrant angle, theta, whose y-coordinate is 0.6612. Now that we have found what theta is, now that we know theta is 41.39 degrees, we could find cosine of theta as well if we wanted to finish that ordered pair. I don't have that written down. Somebody punch cosine of 41.39 degrees. Give me 4 decimal places like I have for the y. 0.7502. So that 0.6612 is not an angle measure. It's not degrees. It's not radians. It's the y-coordinate of a point on the unit circle. And we've used inverse sine to find the angle whose sine was 0.6612. All right. The same thing. This note. The inverse sine function will always return an angle, theta, such that theta is between negative 90 degrees and positive 90 degrees, or theta is between negative pi over 2 and positive pi over 2. We haven't talked about the graphs of the trigonometric functions yet. That's coming up in 5.5. But I have said that the sine function is cyclical, or I'm sure somewhere you've seen a picture of a sine wave. It repeats. Therefore, it does not pass the horizontal line test. Therefore, it is not one-to-one. Therefore, we can't talk about its inverse unless we only use a portion of the domain over which the function is one-to-one. All right? Just like y equals x squared is not one-to-one. We can't talk about the inverse of y equals x squared unless we restrict the domain to either the left half of the parabola or the right half of the parabola. And the same thing for sine. Folks had to sit down, all the math powers that be sat down 1 century and said, okay, we can't talk about the inverse of the sine function over its entire domain from negative infinity to infinity. So what little piece are we going to use? And for reasons we'll talk about more in chapter 6, all the powers that be agreed, let's use the part of the sine function from negative pi over 2 to positive pi over 2, or negative 90 degrees to positive 90 degrees. So when your calculator is in degree mode and you use inverse sine, you're always going to get an answer that's between negative 90 and positive 90. A fourth or first quadrant angle. Now, I'll save that comment for when we run across one in the example. Inverse sine is always going to return a fourth quadrant or first quadrant angle. All right, what about inverse cosine? Solve cosine theta is 0.8 means find the angle whose cosine is 0.8. Find the first quadrant angle whose cosine is 0.8. Well, I'd use the inverse cosine button for that. And when I did, I got that theta would have to be about 36.87 degrees. Or in degrees and minutes, that's 36 degrees and 52 minutes. And just to make sure that I understand what inverse cosine is giving me, I can take the cosine of this 36.87 degrees, and it better give me back the 0.8. So there's this angle in the first quadrant that's about 37 degrees, 36.87 degrees. And there's a point on the unit circle corresponding to that angle whose cosine is 0.8. Now, is that the x or the y? That's the x. So the x coordinate is 0.8. And if I wanted to find the y coordinate corresponding to that angle on the unit circle, how would I find it? Just take the sine of that angle. Somebody punch that for me. I don't have it written. Sine of 36.87. .0081. Anybody second that? Oh, 4. Anybody? That is more what I was expecting. Okay. 0.8-ish, 0.6-ish. And again, cosine is not a one-to-one function. Over its entire domain from negative infinity to infinity, it repeats infinitely many times. So all the mathematical powers that be had to sit down and agree on what restricted portion of cosine we're going to use so that we can define inverse cosine. And all the powers that be decided, well, let's use for cosine quadrant 1 and 2. Now, I don't want that to seem random to you. If you think about it, it kind of makes sense. Inverse sine using quadrant 4 and quadrant 1 gives you all possible y values from -1, from where y is -1 on the negative x-axis to y is +1 on the positive x-axis. So from negative pi over 2 to positive pi over 2, sine hits every possible y value on the unit circle. And then for cosine, from 0 to pi, that's where the x coordinates go from being +1 to -1. So that's an interval that contains every possible x value on the unit circle. Inverse cosine will always return an angle between 0 and 180 degrees or 0 and pi radians. It'll always return an angle in the first or second quadrant. All right, number 30, solve tangent of 4.91 means find the angle whose tangent is 4.91. That means find the angle such that if you took the ordered pair corresponding to that angle on the unit circle and divided the y by the x, you'd get almost 5. Well, use inverse tangent on the calculator and you get 78.49 degrees. Or change that to degrees in minutes and you get about 78 degrees, 29 minutes. So to check that, you could find the tangent of 78 degrees, 49 minutes. And it better be darn close to 4.91. Now, if I'm looking at this approximately 78 degree angle on the unit circle, and the point that corresponds to that, what is the 4.91? Yeah, it's not the y or the x, it's the y divided by the x. If I want to find the ordered pair that corresponds to this angle on the unit circle, what am I going to have to do? To find the x-coordinate, take the cosine of 78.49, and to find the y-coordinate, take the sine of 78.49. But we had to use inverse tangent to find that angle before we could find this ordered pair. Give that to me with 4 decimal places. 1995, okay, and my y? All right. Didn't leave room for my ordered pair there, but does anybody second that? Mr. Nick, that's what you got? All right. We haven't looked at the graph of tangent. I'm playing like I have no idea what it looks like, but I know that if sine and cosine are going to repeat, tangent's going to repeat. So if we're going to talk about inverse tangent, we're going to have to restrict its domain. So all the powers that be sat down and said, what part of the Cartesian coordinate system are we going to use for the restricted domain of tangent? And for reasons that will be more clear later, the same thing was chosen for inverse tangent as for inverse sine. Inverse tangent will always return an angle between negative 90 degrees and positive 90 degrees, or negative pi over 2 to positive pi over 2, or quadrant 4 and quadrant 1, just like inverse sine. Be very careful with number 36. To find the, just listen for a second, to find the, is this cosecant? Cosecant of 30 degrees, you just use 1 over sine 30 degrees, right? We have found cosecant before on the calculator. It's tempting to find the angle whose cosecant is 11 to just do 1 over inverse sine. That wouldn't give you the right answer. Think about why. If there's an angle whose cosecant is 11, what is the sine of that same angle? 1 over 11. If cosecant is 11, then sine is 1 over 11. So if we're going to use inverse sine to find that angle, we don't use 1 over inverse sine. We use inverse sine of 1 over 11. It's the 11 we take the reciprocal of, not the sine. Inverse sine of 1 over 11 is 5.22 degrees, or 5 degrees and 13 minutes. No, to the nearest whole minute, it came out 12 minutes instead of 13 minutes. Is that what you're saying? Okay, I may have just looked at it wrong. I know that, I don't know why it was originally developed this way, but I know that surveyors would use degrees and minutes and seconds, and I know that engineers would use decimal degrees. Now, why they chose to use the different formats or why the two formats were even established, I don't know. But they are used by different professions. That's just like, I wish this notation, this what looks like something to the -1, why even put that there to confuse folks if there's something less confusing like arc sine, arc cosine, arc tangent that means the same thing? Let's just chunk this one out the window. The next big math convention of the universe, I'm going to suggest that. Make secant be the reciprocal of sine and cosecant the reciprocal of cosine. Yes, I'd like to fix that too. And there's something else. Function notation, parentheses meaning either a function or a multiplication. That's not good. That confuses folks. Oh well. The thing to watch out for here, though, if you're looking for inverse cosecant or inverse secant or inverse cotangent, would be a common mistake just to use 1 over inverse sine or 1 over inverse cosine. You have to think about it. If cosecant is 11, then sine is going to be 1 over 11. So to use that, to find the inverse sine, you have to use inverse sine of not 11, but 1 over 11. Notice the difference in the directions for 26 to 36 and the directions 40 and 42. The directions for 26 through 36 just said find the first quadrant angle. Find the acute angle whose trig function is whatever it's supposed to be. But just a minute ago, I said inverse sine will always return an angle in the first or fourth quadrant. Inverse cosine will always return an angle in the first or second quadrant. But really for any positive sine value, there are two angles that have that sign. Sine is positive not only in the first quadrant, but in the second quadrant also. If the calculator is only going to give me the first quadrant angle, I'm going to have to think about it and figure out the second quadrant angle. That's what we do in 40 and 42. Don't just give the acute angle theta, but give all the angles in one complete revolution of the unit circle that satisfy the equation. The calculator is going to give us one of the answers, and then we're going to have to use our smarts to find the other one. But we still want the calculator in degree mode because that's how we want our answers to be given to us. All right, number 40. Sine of theta is 0.8225. Now I know that sine is positive in what two quadrants? That's your y coordinate, so sine is positive in quadrant 1 and quadrant 2. And if I punch inverse sine of 0.8225 on the calculator will give me this quadrant 1 angle theta. But then I'm going to have to use that and find the quadrant 2 angle that would have the same y value. What do you get when you punch inverse sine 0.8225 and round it to the nearest tenth of a degree? That's what I got, 55.3. Think about what you know about reference angles. If this angle in the first quadrant is 55.3 degrees from the x-axis, how would you get the second quadrant angle that's the same distance from the x-axis? 180 minus 55.3. And that's 124.7. See, both of these angles would have the same y coordinate on the unit circle because they're the same height in the Cartesian coordinate system. So if my calculator gives me this one, I can just subtract that from 180 to find the second quadrant angle that the y value would be the same. What about the B part? Cosine, now don't grab your calculator yet. Cosine theta is negative 0.6604. In what two quadrants is cosine negative? That's the x value, and x is negative in the second and the third quadrant. Now look back up at the top of the page to where I wrote a note about cosine. If the calculator is going to give me the second or the first or the second quadrant, well, I know it's not going to give me the first one for this problem because x is not negative in the first one. It's going to give me the second quadrant angle. So there's some angle in the second quadrant whose cosine is negative 0.6604. And I can use inverse cosine to find that. What do you get? That's what I got, 131.3 degrees. That's the second quadrant angle. Where cosine is negative 0.66. But you told me that there's also a third quadrant angle. You see why it would have to be right here? Cosine is your x-coordinate. Your x-coordinates are the same here and here. We've gone the same distance to the left of the origin from here to here. So how can I find the angle in the second quadrant, or excuse me, third quadrant that has this as its terminal side? There are different ways to think about it. The first thing that pops in my mind is if this second quadrant angle is about 130 degrees, that's about 50 degrees shy of the negative x-axis. So to get the same angle in the third quadrant, I just add about 50 degrees to the 180 degree negative x-axis. So I know it's about 180 plus 50. I know it's about what's bugging me? Yeah, I'm not sure what was bugging me. 180 and another 50 is about 230. You would get that same thing if you just subtracted, let's see, how can I show this big angle? I need a different color pen here. That big angle is 360 degrees minus 131.3. Or 228.7. The way that occurred to me to get that angle is not the same way that occurred to Tori, and that's okay. I just said, for me, I said in the second quadrant, I'm 50 degrees short of the x-axis. So in the third quadrant, I need to be 50 degrees past the x-axis, or add 50 to 180, and I got the same thing. All right, what about the D part? Cotangent 1.3752. Before you grab your calculator, in what two quadrants would cotangent be positive? Whatever quadrants the x divided by the y would give you a positive, and that's whatever quadrants the x and the y have the same signs, where they're both positive in the first, where they're both negative in the third. So I'm going to have to use inverse tangent here, but not 1 over inverse tangent. I'm going to have to think, if cotangent is this, then what is tangent? Yeah. Well, think about this cosecant problem up here. If cosecant is 11, then sine is 1 over 11? Yeah. If cotangent's about 1.4, then tangent is about 1 over 1.4. So when I use my inverse tangent button, I don't do 1 over inverse tangent. I do inverse tangent of 1 over 1.3752. And that gives me approximately a 36-degree angle. Anybody second that? Okay, about a 36-degree angle. That's my first quadrant angle, whose tangent is 1 over 1.3752. You told me that there's going to be a third quadrant angle with the same value for cotangent. It's going to have to be where the x and the y are the same, except for both negative. So how can I find this big angle? Well, that would give you the same thing. Yeah, that would give you, that's two different ways of thinking about it. If this is 36 degrees shy of the positive x-axis, we could go 36 degrees past the negative x-axis, or 36 degrees past 180 would give us 216. Or another way to think about it is 180 degrees from 36, just add 180 to 36. The great thing about this is these answers are checkable. If I, how could I check that? Again, I'm confused about this cotangent thing. I'm not sure what to take the reciprocal of. How would I check and make sure that that 36 degrees actually is one of the values of theta that make that equation true? Right. Cotangent 36 degrees is 1 over tangent 36 degrees, and that better give me something darn close to 1.3752. Does it? Good. All right. One more problem with our calculator in degree mode, and then in 42 we'll need to change it to radian mode. Part F, if you tell me cosecant theta is negative 2.3179, I automatically think then sine theta is what? 1 over that. So to find theta, I'm going to have to use inverse sine of -1 over 2.3179. And I got that to be, let's see, to the nearest tenth of a degree, 334.4. And what quadrant is that angle? Yeah, that's almost 360 degrees. It's all the way from here to here. That's 334.4 degrees. What other quadrant is going to have an angle whose sine is negative? Inverse sine. Oh, I know why. Because your calculator's always going to, in degree mode, it's always going to return you an angle between -90 and 90. Your -25 degrees is between -90 and +90. My 330.4 degrees is not. It is still, however, in the interval that I want my answer to be. My calculator gave me the 25 degrees, which is in the, wait, you said -25. It gave me the -25 degrees. It gave me this angle, but not in the interval that I wanted it written in. -25 is not between 0 and 360. So I had to take that -25 and change it to a coterminal angle. That's where I got the 340 or 334.4. Just by adding 360 to the -25. Still, the calculator gave me my fourth quadrant angle. In what other quadrant would there be an angle whose sine was negative? In the third quadrant, there would be another angle that had the same y value. You could tell that these two angles would have the same height or same y value. If this one is 25 degrees below the positive x-axis, this one's going to be 25 degrees below the negative x-axis. How would I get it? 180 plus approximately 25. Yeah, 25.6. $180 plus 25.6 is 205.6. Just make sure that your answers are in the interval that you're asked for, and -25 was not. All right, all we have to do differently on number 42 is put the calculator in radian mode. So make sure you make a note on number 40 to have your calculator in degree mode, because that's what you want the calculator to give you. And then 42, make sure you have your calculator in radian mode, because that's what you want the calculator to give you. And we want to give all solutions in one revolution of the unit circle from 0 to 2 pi. Notice the 0 is included and the 2 pi is not. in order to keep this a one-to-one function. 0 and 2 pi are the same thing, so I can't include them both or I won't have a one-to-one circle or one-to-one function. All right, with the calculator in radian mode, tell me the angle whose sine is negative 0.0135. The angle whose sine. You have to use the inverse sine button to find it. I got, was it negative 0.0135? Okay, but is that between 0 and 2 pi? It's not a number between 0 and 6.28. So when my calculator gives me approximately negative 0.0, let's see, I'm going to round to the nearest hundred, so negative 0.01. That's radians, and I have to think, but wait, that's not between 0 and 2 pi. It's a little bitty angle right here. What's the coterminal angle that is between 0 and 2 pi, or how would I get that coterminal angle? Add 2 pi to negative 0.01, or I was thinking 2 pi minus 0.01 would give me the same thing. That's approximately 6.27. And that is a number between 2 pi is about 6.28. That's between 0 and 6.28. It's darn close to 6.28, only 1/100th of a radian below that. Because that's radians, I don't have to write the units. It's understood to be radians. In what other quadrant is there an angle that has the same negative sine value? Yep, sine's the y's. The y's are negative in the third quadrant. Yep. If you want the third quadrant angle that's 0.01 past pi radians, then just add 0.01 to pi, and 3.15 is your third quadrant angle. All right. Because we won't have time to do 3 more, let's just do the D part. I don't have an inverse cotangent button. I have an inverse tangent button. So I have to think, if cotangent is about negative 2.7, what's tangent? 1 over negative 2.7. So inverse tangent of 1 over negative 2.731 that's the one I don't have written down. You'll have to tell me. About how many radians is that? Inverse tangent of 1 over negative 2.731 to the nearest 100th. Anybody second that? Okay. So again, that is a very small distance from the positive x-axis in the third quadrant, or excuse me, fourth quadrant. But that's not a number between 0 and 2 pi. So how would I find the coterminal angle? Just add 2 pi to that. 6.28 minus 0.35. 5.93 is a number between 0 and 6.28. And then what other quadrant are you going to have an angle whose tangent and cotangent are negative? Cotangent and tangent are positive where the signs are the same. That's the first and the third quadrant. They're both negative where the signs of x and y are different. And that's second and fourth quadrant. So how could I get that same second quadrant angle whose... Okay, you could just add 180 degrees to this, or since we're talking about radians, add pi radians to this negative 3.35, or excuse me, negative 0.35. Actually, the way I was thinking of it was this is about a third of a radian below the positive x-axis. This is a third of a radian above the negative x-axis, so I would just do pi minus 0.35. This has to be 0.35 radians, so pi minus 0.35 would give me my second quadrant angle. And what's that? 2.79. Makes sense because pi is 180 degrees is pi radians, or 3.14. This is just a little bit shy of 3.14. All right. There's how the homework was supposed to be broken up, 1 through 23 and 37 last night, and that leaves these for tonight. But just do whatever you haven't done and finish up whatever this is, 5.4. Finish up 5.4 tonight. It's 1 through 41.